Hello everyone, let's talk about another medium problem on Leetcode today. Delete leaves with a given value, Leetcode 1325. In this problem, we are given a binary tree root, an integer target, and we have to delete all the leaf nodes with the value target. And the important thing to note is like we have to continue doing it until there is no leaf node with a target value. So let's look at some examples here. So in the example one, we can see that target is 2 and this is the given tree, and when the two leaves exist for target equal to 2, we remove them, but then we get this tree, right? And then eventually this is also the leaf node with target equal to 2, so we just delete that and then we get this kind of a tree. Here the case is simple because we have two leaves, right? And here again the value is equal to 3, so we remove them. But now once we remove, we get a tree like this, and this is not a leaf. This node with value equal to 3 is not a leaf node. And finally, this is a good example where we just keep on deleting 2's till all leaf nodes with target equal to 2 are removed from the tree. Now that we have understood the problem, let's jump into the solution space. Let's look at the example again just to understand the problem a bit more. So if you look closely, we have target equal to 2 and leaf node, like there are two leaf nodes currently in the present tree. So what we do is like we process them, that is we remove them, and then we get the tree in this form. And then that means we first process the leaf nodes, then we process their parent. And which traversal does that in binary tree? It is post order traversal. So the idea is simple. First we process the leaf node, then we process the parent, and we will keep on processing it till we have removed all the leaf nodes with target equal to 2. Now let's look at above idea with the example. So we start with the root node where the value is equal to 1, right? But we first have to process its left and right children. So suppose we go traverse to the left side first. Then we see, is this value a leaf node? Answer is no. So we go down further. Is this value a leaf node and is it equal to target? And the answer to both of the points is yes. So we will remove it and get back to the what do you say, calling parent in the stack. So we go up and see, is this a leaf node now? And is it also a and actually it's a leaf node because it does not have any other child. And is the value is equal to target equal to 2? Answer is yes. So we will also remove it. Now we like go back to parent, but we will still not process it, right? We have to process the right child still. So now we do the DFS on the right side. So we see is 3. So first we go to 3. We know that it has child, so we go deeper. We go to 2, and is it a leaf node? Answer is yes. And again, is it equal to target? So yes. So we will remove it. Then we go back to 3, but we again come to 4 because we have to still process the second child or the right child. And again we check, is it a leaf node? Answer is yes. And is it equal to target? Answer is no. So we will keep this one, right? So this leaf point will stay. Now we go up. Both the children have been processed, so we see, is it a leaf node? Answer is no. We go up. Then we go to 1. Is it a leaf node? And answer is no. So we will return this tree in one go, right? So that's how the post order traversal will work. Now let's jump into the code part. So first thing we have to check is if our parent is already null, we don't have to do anything, right? So we will just return what you say, root in this case. Otherwise, what we will do is like we will first let's say process the left child, and we will say, okay, remove leaf nodes, right? And we'll pass root dot left and target. Similarly, we will do the same thing for the right child and process the right subtree as well. And once that we are done, like now we will process the parent. So it will be like root dot, if root dot left is equal to null and root dot right is equal to null, right? And root dot value is equal to target. That means this should also be removed. So we will return null in this case to the calling function. Otherwise, we will just return root. That's it. And I think once we run, we can actually see how it goes. Cool. Then in terms of time complexity, we can see that we are processing all the nodes in the left and right subtree. So that means it's O of n. And in terms of space complexity is again O of n, assuming that we are using recursive stack. I hope this video was useful to you. If it was, please like and subscribe. Thank you.